Hey you guys, so here's a quick video that should help you if you struggled with these problems on the worksheet. If you're doing corrections or you know you did some things wrong, welcome to come back in and take a second look at your work, even if it's graded and you got a grade for it. So this is factoring when your leading coefficient is not 1. So I've done a couple examples where I'm going to do one here where there's just one type of variable, and down here where there's two types. This is the type that you'll see in Khan Academy, there was a topic called factoring with two variables. So in both these cases, a will not equal 1. So let's get started. So the first thing that I look for always is a common factor. So in this case, I notice that 64, 32, and 12 can all be divided, at least from my first glance at this problem. I see that I can divide 2 out. I also notice that I can take an x out of all my terms. So let me go ahead and start with that. Now when I divide out 2x, basically what I'm doing is dividing every term by 2x. So 64 divided by 2 is 32. X cubed divided by x is x squared. Negative 32 divided by 2 is negative 16. X squared divided by x is just x. Negative 12 by 2 is negative 6. And x divided by x is 1. Now that I've pulled out my common factor, I notice all of these are divisible by 2 again. So what that means is that if I put another 2 on the outside, I'd have 2 times 2. So really 4 was my common factor. So let me add all by this would be 16x squared minus 8x minus 3. Just double check, if I multiplied, I'd get 64, negative 32, and negative 12. So that is my greatest common factor. Now I'm going to try to look here to see if I can factor this polynomial further. I may or may not be able to. So I know that if I am able to break it down, that what goes in the first position parentheses has to multiply to 16x squared. So if I'm looking at this, I have either 1 times 16, 2 times 8, or 4 times 4. And if I take out, and I know in my second position, it always has to multiply to my constant. So in this I know it has to be 3 and 1. And I know that one's going to have to be negative, one's going to have to be positive. I'm not sure which one, so I'm just going to start by guessing, and I'll check. Let's try 2x and 8x. So all you have to check are your outside terms and your inside terms. You don't have to check the first, multiplying the first ones or the last ones, because you picked them so that they guaranteed the first and the last were correct. So if I multiply this out, I'd have 6x minus 8x. That would give me negative 2x. So that wouldn't work. So I put the 8 here and the 2 here. If I just switch the position, that's going to change up my terms. So let me see if that's going to work. So I'd have 24x minus 2x. No, that'd be 22. Both positions, and it never got even positive 8 x. I know that it can't be 8 and 2. 1 and 16 seems pretty extreme, so I'm going to try my 4 and 4. So let's try 4 and 4. So the outside terms, the O and the I of FOIL, outside terms would make 12x minus 4x gives me positive 8x. Since I want negative 8x, if you're only off by a sign, switch the signs in your parentheses. So we'll make the 1 positive, the 3 negative. Therefore, that will give me negative 12 on the outside, positive 4 on the inside, and those two will add up to my negative 8x. So therefore, my winning combination was 4x plus 1 to 4x minus 3, and then I still have this factor out here of 4x. Now, if this problem was a solving problem, so if there was an equal sign, let me go ahead and revise this. Obviously, it had to all be on one side. I wouldn't be done with my problem yet. I have to set each factor equal to 0. Technically, there's two factors out here, 4 and x, but since they're being multiplied, divide by 4, so I get x equals 0. Use SADMEP, add 1 to, or subtract 1 from both sides, divide by 4. There's my solution. Add 3 and divide by 4. So I get 3/4, negative 1/4, and 0 as my solutions. Again, you would only do this if it was equal to 0. If it didn't have equal to 0, you'd be done at that point right there. All right, let's move on to the next problem. So first thing I'm going to do is look for a common factor. I see that all of these can be divided by 2. I see, dang, None of them have variables that they all have in common. These two have x's and these two have y's, but all have x's, don't all have y's, so I can't take any variables out. So if I divide everything by 2, I would get 5x squared minus 18xy plus 9y squared. This might be as far as I can go. Technically it's factored. I've broke it into 2 times this whole polynomial, so that's a times b. But let me see if I can break down what's in parentheses. So the first position has to multiply to 5x squared. 5 is a prime number. There's only one choice. It has to be 1 times 5. So I'm going to put 5x and x. Now in my second positions here, they have to multiply 9y squared. So a couple more options, either 1 and 9 or 3 and 3. So I'm going to start with 3y and 3y. Now they both have to multiply together to make a positive y squared. And since my middle term's negative, in this case I know they both have to be negative. Only a negative times a negative or a positive times a positive would make a positive. And let me double check. Well, let's check my middle term. 5x times negative 3y would make negative 15xy. And negative 3y times x would make a negative 3yx or xy, doesn't matter since they're being multiplied. And these two guys add up to negative 18. So therefore I know that this is as far as I can go. And again, because there wasn't an equal sign, and I'm not going to bother showing you, I just added the equals 0 to this first problem to show you how you'd finish if it was a solving problem. But in this case, the instructions for this one would be to simply factor completely. So on a test or quiz, if a student stopped at this point, they'd probably only get maybe 1 out of 4 points because they just took out the common factor. The other 3 points came with the more challenging part, which was finding the correct combination of terms that multiply together to make a polynomial. Now, again, for emphasis, sometimes you can't break down this polynomial further. So anyhow, I hope this helped, and feel free to come in any time if you'd like to work or you have questions. I'm available usually by 8 in the morning and at lunch every day, except this Thursday. I won't be here for a staff meeting. See you later.